Hello, I'm Marcus from SDP Team 4, and we're going to talk about our implementation of CTNG, an improved public key infrastructure scheme. Certificate transparency, or CT, is the backbone of modern web security, but comes with a variety of problems. CT Next Generation is a proposal by Hertzberg et al. Outlined in CTNG, Secure Certificate and Revocation Transparency. The proposal aims to fix those problems in a way that builds on existing code and requires little bandwidth or overhead to implement. Certificates are used by websites to prove to browsers that information is being securely transported. While CT was originally designed to support revoking those certificates in the event of detecting misbehaviors, this functionality has been left behind, leaving no mechanism for punishing those who abuse the system. CT has also abandoned the idea of no trusted third party. With this, no one entity has too much control over the system, and bad actors will have a much harder time infiltrating it or brute forcing their malicious behaviors. We have been tasked with creating a design specification for the solutions outlined by CTNG, as well as creating a test environment to prove the concept can work in practice. In our specification, we designed a concrete API for implementing CTNG. From the high-level outline, we developed a network in which individual entities all work together to verify data. At the core of CTNG is the monitor, which decides if certificate data is trustworthy and should be sent throughout the network. Monitors detect and report misbehaviors, as well as keep track of certificates that have been revoked by examining certificate logs. These revocations are then shared with relying parties such as web browsers. Connected to every monitor is a gossiper. This does exactly what it sounds like, gossiping data to other entities it is connected to in the network. Gossipers all exist as HTTP servers and communicate using a RESTful API, allowing for scalability and generalization. In fact, they are designed to send generic JSON objects that allow for use in any project that needs a network of synchronized and decentralized data. Now I'll hand it off to Finn for a short demonstration of our system in action.
We will now give a demo of the distribution of data through our network. Each of these windows is a gossiper, whose duty is to distribute data to its connections in the network. You can think of each of these windows as a separate computer interacting with each other through the drawn lines. We will now send data called a gossip object into the bottom left gossiper and watch it be distributed through the network. This happens very quickly. Notice how despite not being connected to the bottom left gossiper, the top left gossiper receives the sent data. This is because whenever a gossiper receives information, it distributes that information to all of its gossipers. This process is therefore decentralized in nature. Therefore, it's important that a gossiper's connections can be trusted and reliable. So, if a gossiper is inactive for an extended period of time, it should be considered suspicious, as it could be trying to prevent information from being distributed appropriately. And so we'll now disconnect the top left gossiper and show how the other gossipers react when data is sent through the system. Now when we send information through the network, the connections of the top left gossiper notice it can't be connected to and create an accusation. These accusations are then sent to the network. When a gossiper receives enough accusations from other gossipers, it generates a proof of misbehavior. Notice here every gossiper has generated its own proof of misbehavior. A proof of misbehavior is a cryptographic proof that the network agrees that it cannot rely on a given party. Now let's see what happens when we reconnect this gossiper and send a new object through the network. You can quickly see that this gossiper has not received that information. This is because it's been deemed untrustworthy by the rest of the members of the network. There are a number of ways that a specific entity can be deemed untrustworthy, but it always results in a proof of misbehavior for that specific entity. Because the network as a whole is deciding that this party is untrustworthy without relying on the jurisdiction of a single party, the system we've created supports the no trusted third party principle of certificate transparency.
We hope you learned a little bit about web security and our work to improve it for everyone. Thanks for watching.